Hi everyone and welcome to my channel. Today we will be diving into the world of LeetCode and solving the linked list cycle problem. The problem is simple on the surface. We need to determine if a given linked list has a cycle. However, the devil is in the details. To intuitively grasp our solutions, let's break them down one by one. We have two solutions for this problem. Solution one is Floyd's Tortoise and Hare algorithm. In this approach, we use two pointers, slow and fast, initially pointing to the head of the linked list. The fast pointer moves twice as fast as the slow pointer, simulating a tortoise and hare race. If there is a cycle, the fast pointer will eventually catch up to the slow pointer, and we can conclude that there is a cycle. Let's break down the code. First, we define a class named solution with the method hasCycle. It takes two arguments, self, which is a reference to the instance of the class, and head, which is a reference to the head node of the linked list. It returns a Boolean value indicating whether a cycle exists. And here, two pointers, slow and fast, are initialized to the head of the linked list. Both pointers start at the same node. Then the code begins a while loop that continues as long as the conditions fast and fast next are not known. In other words, it checks if both are fast and the next node of the fast exist. The loop continues while we are safe to advance both pointers without encountering a non-reference. This is essential to avoid runtime error. And next, in this line, the slow pointer is moved one step forward in the linked list by assigning slow next to slow. And then the slow pointer advances gradually, moving from one node to the next with each iteration of the loop. Similarly, the fast pointer is moved two steps forward in the linked list by assigning fast next to fast. The fast pointer moves faster, skipping one node with each iteration of the loop. This simulates a race between the two pointers. When slow and fast meet, it implies that a cycle has been detected in the linked list, and then the algorithm should return true. Then we use this line to check if the slow and fast pointers have become equal, indicating that they have met at the same node in the linked list. If a cycle is detected, the solution returns true, indicating that a cycle exists in the linked list. If the loop completes without finding a cycle, it returns false, indicating that no cycle exists in the linked list. So in summary, the code implements Floyd's tortoise and hare algorithm, which is an efficient way to detect cycles in a linked list. By advancing two pointers at different speeds, the algorithm detects a cycle when the fast pointer catches up to the slow pointer. This indicates that the linked list contains a cycle. If the fast pointer reaches the end of the list without meeting the slow pointer, it means there's no cycle. The time complexity of this solution is big O of n, where n is the number of nodes in the linked list, because in the worst case, both pointers traverse the entire list once. The space complexity is big O of 1, since we only use two extra pointers, slow and fast, regardless of the size of the linked list. Now, Let's take a close look of the solution 2, which is the hashing approach. The intuition behind this solution is straightforward and relies on marking visited nodes within the linked list. Here's how it works. First, we start at the head of the linked list. As we traverse the linked list, we mark each visited node by setting its value attribute to a specific value. In this case, it's 10 to the power of 6. If we encounter a node with its value already set to 10 to the power of 6 during traversal, it indicates that we have visited this node before, which means there's a cycle in a linked list. In this case, we return true to indicate the presence of a cycle. If the traversal completes without finding a node with value equal to 10 to a power of 6, it implies that there's no cycle in the linked list, and we return false. The core idea here is that by marking visited nodes, we can detect cycles because we will revisit a marked node if and only if there is a cycle. In summary, this code implements a hash marking approach to detect cycles in a linked list. It marks visited nodes by modifying their value attributes. When a marked node is encountered again during traversal, it indicates the presence of a cycle. Similar to solution 1, the time complexity of this solution is big O of n, where n is the number of nodes in the linked list. The traversal of the entire list is required to mark visited nodes and detect a cycle. The space complexity of this solution is big O of 1 as well, although we modify the value attribute of each node, and we are not using any additional data structures that depend on the size of the linked list. The space used is constant and does not grow with the input size. As you can see, both solutions have a time complexity of big O of n because they traverse the entire linked list in the worst case to detect a cycle. However, they excel in terms of space complexity, with both having a space complexity of big O of 1, making them efficient in terms of memory usage. I hope this tutorial has been helpful in understanding how to solve the linked list cycle problem on LeetCode. Remember, practice makes perfect. Keep coding, keep learning, and you will ace these coding challenges in no time. And if you found this video informative and want to see more tutorials like this, please hit the like button, subscribe to my channel, and don't forget to leave your comments and questions below. Thanks for watching and happy coding! Goodbye!